Have you ever wondered how everything in the universe began? How did galaxies form and where did all those stars come from? Well, there's a lot of science behind it, but I'll try to break it down for you in this video. So if you want to learn more about the universe and how it works, then be sure to subscribe. We've got lots of fun stuff planned for the future. I'm a physics teacher with a passion for making physics fun and understandable. Alright, let's get into it. The universe is expanding and it's getting older every second. It may sound strange, but both of these things are evidence that the Big Bang Theory is right. This plasma contained mostly hydrogen and helium and trace amounts of other elements. Energy. The big question is, how do we get the first star to turn on? Well, if a piece of matter is sufficiently small, quantum effects will cause it to fluctuate in size. This is called the uncertainty principle. Counteracts, then gravity will take over and pull the object back together into a smaller sphere. This makes the density even higher and the process repeats, causing the object to shrink even more. Once a star turns on, it will produce heavier elements in its core through nuclear fusion. When the star runs out of fuel, enriched dust contains elements heavier than helium, such as carbon, oxygen and iron. The heavier elements are less abundant, so they're not good at clumping together and forming new stars on their own. They act as seeds for stars to form around. It will explode and throw these heavy elements into space. This allows the next generation of stars to form more easily. It also allowed for life to develop on Earth because without elements like carbon and oxygen, life as we know it couldn't exist. Now what about galaxies? How do all those stars form a galaxy? Stars can also form around this enriched dust by capturing it and adding it to their cores. As the gas collapsed, it would spin faster and faster due to conservation of angular momentum. Once the wave passes, the gas expands and the new stars form. Elliptical galaxies don't have well-defined arms and their stars are more evenly distributed throughout the galaxy. When galaxies collide, their stars and gas clouds are thrown into a more random distribution, resulting in a more spherical shape. They also tend to have fewer gas and dust clouds, meaning that star formation is less active. They may have also formed through the merging of smaller clouds of gas. This would form a disk with a bulge in the center. It's a complex process that scientists are still trying to understand. But hopefully this video has given you a better understanding of the universe and how everything began. The ball will just keep going faster and faster as it goes further and further down the hill. Dwarf galaxies are smaller versions of spiral galaxies. They usually have a large central bulge and a disk of stars with some gas and dust clouds. Some dwarf galaxies have very few stars, while others have millions or even billions. Similarly, and as always, remember to keep an open mind and never stop questioning. The object. The first galaxies were probably irregular in shape and had no defined structure. This caused the galaxies to take on a more spherical shape. The old stars tend to be found in a bulge in the middle of the galaxy and the arms are mostly made up of gas and dust where new stars are forming. The arms themselves are regions of active star formation because of a wave of star formation that moves through them. Over billions of years, these spherical galaxies would evolve into the spiral galaxies we see today. However, as the universe continued to expand and evolve, these galaxies began to interact with each other more frequently. Needs to be small enough for quantum effects to cause the density fluctuations necessary to start the collapse. Eventually, so we think that the first stars probably formed out of hydrogen. A hydrogen sphere needs to be around 2 million kilometers in diameter to form a star. That's about 2/3 the size of the Sun. The object reaches a critical size where nuclear fusion takes over and turns the object into a star. The force of gravity which was pulling the star together and keeps the star from collapsing under its own weight. If gravity wins, the star will collapse. If nuclear fusion wins, the star will expand outward. For a star to be stable, these two forces need to balance each other out. As the universe continued to expand and cool, the particles in the plasma started to slow down and clump together. These clumps eventually became the stars and galaxies we see today. What does the Big Bang Theory say? Well, pretty simply put, it means that our universe began from a single point and that point expanded. As the ball rolls down, it speeds up. This is just like the shrinking object as it becomes more dense. If the ball reaches the bottom of the hill, it stops and turns around and goes back up the hill. This is just like the star which can't collapse because the forces of fusion and gravity balance each other out. As the universe expanded, it was filled with hot, dense plasma. But as the universe expanded and cooled, particles slowed down and clumped together into massive clouds of gas. These clouds were called nebulae. Over billions of years, these clumps of gas would grow larger and larger through gravitational collapse. But how did the first stars turn on? Well, let's start at the beginning. This process is called nuclear fusion and is what powers our Sun. When atoms are smashed together really hard like in the core of a star, they combine to form bigger atoms and release a tremendous amount of energy. You have your hot plasma, and we know from experience that when you heat up a gas, it becomes less dense because the particles move faster and spread out. But if the gas is slightly uneven, those particles will eventually collide and slow each other down. Eventually they can become so slow that gravity takes over and pulls them together. In the early universe, the particles were moving really fast, so it took a while for this to happen. Eventually the core of the nebula became so dense that it caused the hydrogen atoms to smash into each other and fuse together, creating helium. This so once a star begins to shine, it will remain stable until it runs out of fuel. If this fluctuation causes the density to increase, it's kind of like a ball rolling down a hill. The key thing here is that the ball needs a hill to roll down. Without a hill, the exact mass needed varies depending on the composition of the object. Hydrogen is the most abundant element in the universe, so it seems likely that the first stars were roughly the size of our Sun or slightly larger. These heavy elements form what is called enriched dust. Enriched dust particles stick to each other and to any hydrogen or helium near them, causing them to collect in greater quantities. This enrichment of the dust with heavy elements played a huge role in the development of the universe because it provided the raw material for planets and other objects like asteroids and comets. So it's kind of ironic that it was the explosion of a star that created the conditions for life to develop. Well, it's thought that the first galaxies formed in much the same way that stars did, through the collapse of a large cloud of gas. Stars would form in this disk as the gas collapsed. As galaxies interacted, they would exchange stars and gas, which led to a more even distribution of matter. Spiral galaxies contain both old stars in the center and new stars in the arms. As the wave moves through, it compresses the gas, causing it to collapse and form new stars. In addition to spiral galaxies, there are also elliptical galaxies. Elliptical galaxies are thought to form when two or more galaxies collide. And finally, there are dwarf galaxies. Dwarf galaxies are thought to have formed in much the same way that spiral galaxies did, but on a smaller scale. So there you have it, a brief overview of how galaxies and stars form. Thanks for watching. If you enjoyed the video, please remember to subscribe and check out my other videos.